This is a outdoor solar light, well, it could be indoor as well, but it's designed to emulate a sort of flaming lantern, but it does so with very low power, and it's quite an interesting circuit board inside. So before we start, I'll turn the light off and you can actually see what this looks like. So the pattern is very simple. If you look at the top, you'll see that it repeats roughly every 2 seconds, but at the base, it glows up and down in a much slower speed. So it's basically sliding two patterns against each other to provide a bit of variety. And it works quite well. It is very simple. Let's open it up and take a look inside. So watch your eyes, the light is coming back. And the light is back. So I shall lock the exposure off now. And I shall open this up to reveal that it has a very simple circuit board inside. It's one of the most minimalist flame effects possible, really. But that's down to the fact that it has to run at low power. So there's a little circuit board in here with just a little ubiquitous 8-pin chip. And on the top, we've got a fairly decent, roughly 50mm, 2-inch square amorphous silicon panel, which is very good. Let's open it up and reverse engineer it. So the LEDs, the pattern is divided. This is the bottom. It's these two that dim up and down, and it's these ones that actually replay the pattern. And as it comes in the packaging, you've got a little socket here that a button can bypass the on-off switch, so you can actually power it in the packaging by pushing the button. It's quite a neat presentation. It came from Jack's Home Stores in Ramsey in the Isle of Man. They've got branches all over the Isle of Man. It seems to be mainly a sort of Isle of Manish type company, I think. So this is not popping out. Let's see if it's clipped in. It's more than clipped in. It feels really tight. I shall gently slide round and see if there's any clips or something. Or maybe it's glue. No, nothing yet. Oh, is something holding it in the middle? Is this not going to come apart too easily? Let's take a wee peek down inside with a flashlight just to see what is holding this shut. I have a sneaky feeling they may have glued the thing together as well. So there's definitely a bit of glue there. Where is a flashlight? And I'll just point this down the inside. It's glued. Oh, darn. Right, tell you what. I'm going to pause momentarily while I just go and get something to drip some isopropyl alcohol into that. So just, I'll be back in a moment. 1 moment, please. I have some isopropanol, also from Jack's. Let's squirt it down the inside here. See if I can drizzle it down onto the glue. And we'll see if we can separate it that way. There's a good chance it may find its way under the solar panel as well. That's not necessarily so great because it is probably held in by hot melt glue as well. Okay. I'm just going to put, oh, there we go. Instant effect. Wow. That is such a good technique. Hold on, I'm just going to tip this out. It's only isopropyl alcohol. What's the worst could happen? So that, if it if you were to pour it on the top, it would probably liberate solar panels. I wonder how well that would work. I'm kind of tempted to try that now. So what do we have here? We have the circuit board is actually built onto the actual... I thought this was going to be a separate solar unit and then a separate flame circuit board, but it's not. Have I managed to loosen that all up, or does it require a little sploosh more of this? Let's just sploosh it everywhere and see if we can loosen the whole thing up. The isopropyl alcohol and even I think methylated spirits also has a profound effect on hot melt glue. It just makes it seems to loosen it up and then get in between by capillary action, and then it just works its way through. It's quite a dramatic effect. You have to be careful not to contaminate surfaces with isopropanol when you're hot melt gluing, because or hot melt glues in the vicinity where it causes problems. So what I'm seeing here, I'm seeing a little tiny chip, which is probably the right. I'll get this out. That's the best bet, and then we can take a much closer look. The circuitry is reverse engineered. Let's explore it. So the most obvious components here, the ubiquitous 8-pin microcontroller, possibly a PADOC. I actually don't know if it is. It's got the standard pinout of the PIC microcontroller and other variants. There's the inductor. It's blue, grey, black, 6, 8, and a multiplier of 0, so that's just 6 to 8 microhenries. In this instance, they've chosen a lower value inductor because they're looking for a higher current from the unit, and that's compensated for by the large solar panel underneath there. This solar panel here, I've just tipped all the screws out. And is the battery got a decent capacity, or is it 300 milliamp power? Let me just check that. It's 300 milliamp power, supposedly. AAA. The circuitry has a smoothing capacitor, and if you look at the back of the circuit board, this is the circuit board, smaller, but the same circuit board, and it's got the little chip, but it's not the standard 4-pin chip. It's a 6-pin chip, but it's using 4 pins. And instead of the usual solar garden light chip, this one actually has a common positive as opposed to a common negative. It also has this little diode here, which forms part of a little a rectifier, effectively, to take the pulses from this inductor that step the voltage up and feed them over to this capacitor to provide a smooth supply over to this microcontroller. The microcontroller feeds the LEDs. The positive goes out to the LEDs, and then there's just 1 pin per pair of LEDs. The pair of LEDs relates to the one on this side of the circuit board and the one on the other side, because the image is just echoed from one side to the other. So that from the top of the circuit board down to the bottom, it's numbered. The connections are numbered 1, 2, 3, 4, 5, and 6, with 5 and 6 actually just kind of dimming up and down together, which is strange because while I was reverse engineering this, I remembered this little light, which is pretty much identical, except it doesn't have one diode for a specific reason, and it's got a surface mount inductor. But this one's odd because the 2 LEDs at the bottom, they modulate sort of backwards and forwards. They seem to modulate up and down independently, but this bit here just does this continuous rhythmic sort of pulse, 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 pulse. There's no sort of pattern to it. At least that one had it's short, it's every 2 seconds, but at least it tried to do that sort of flame departing from the top of the sort of the flame effect. But this is more or less, it's a very similar style of circuit board, but it just has one little diode less, and I shall show you why that is. I shall put this back together, turn it off. This was supposed to be taken apart earlier, but didn't get taken apart. Now it's kind of been gazumped by this one, this bigger and grander one. So yeah, the circuitry in the back has this little 6-pin chip, which is roughly the equivalent of the standard 4-pin YX chip, but this one is called AatLB. It actually says that A and then lowercase letters, at and then LB. I'm not really sure what that means. Maybe that's a secret address. Maybe LB is named the company, and AatLB finds the company involved. But it's not the sort of chip that, you know, the average person would need, because it's kind of designed for the manufacturing industry for cheap Chinese lights. Oh, so this diode here, this chip, when it turns, when it wants to boost the voltage, when it gets dark, it detects the voltage from the solar panels gone down, and it starts pulsing this inductor. That generates a higher voltage which goes through this diode and charges that capacitor, and that capacitor then supplies the chip. This is an auxiliary diode. It's odd, but it's quite neat in a way as well. And this allows the battery to be charged more efficiently because it's got a lower voltage drop. But it also means that it can also charge the solar panel even when this unit is switched off. I shall show you the circuitry. Here is the schematic. I shall zoom in on it. I shall zoom in on it, but then not too much, because I kind of like this little thing at the side that is showing you what the circuitry does. So it's unusual that this chip, AatLB, has a common, the solar panel and the nickel metal hydride cell are both common to positive. Normally the YX chip sits common to negative. So normally it wouldn't have this diode here. This is the mystery diode that allows the charging when it's not turned on. Normally that wouldn't be there, and when turned off it would just disconnect the battery from the circuit completely. In this case, the solar panel, when it's turned on, would normally charge the battery via this internal diode, which is a voltage drop of 0.6 volts, a standard silicon diode. So there's an advantage to having this one, which is a Schottky diode, which has a drop of 0.2 volts that will be more efficient. But the input also monitors the voltage from the solar panel. When it sees that it's going close to the positive rail, it means that it's getting dark outside, and that's when it turns on. That's when it starts bridging this inductor from the positive. It bridges it via a little, say, a MOSFET. or other transistor, it bridges it to the negative rail. And when it does that, normally the voltage from this is about 1.2 volts. It's not enough to actually make the processor start up. But when 1.2 volts minus the drop across this diode. But when this turns on, this is positive and this pulls negative, and it puts a certain amount of charge onto that inductor. But then it turns off, and then the field collapses. So this is negative, this is positive. That then adds on to the 1.2 volt, and it boosts the voltage up and charges this capacitor, and that's what powers the circuitry. But that only happens when it gets dark. This diode here is the one that allows that charging. When this is turned off, it disables the rest of the circuitry, but any charge going onto the solar panel will be able to find its way via this diode to the nickel metal hydride cell and keep it topped up. I guess ultimately this came in a cardboard box that I think was fully closed. Maybe not. Where was the box? I think I've scrapped the box. No, I haven't. Was it? No, it was. It was fully closed. Jack Stores. Arezzo flaming torch or whatever it is. Flamand Fakel Arezzo. Oh, right, okay, lots of languages. Is this from this Dutch company again, this Dutch import company? Smart Garden Products, 2 Pentagon South, Barton Lane, Oxfordshire. www.sgpuk.com. Okay. No mains wiring needed. So when it gets dark and this turns on and it is switched on, it generates that DC voltage which powers the microcontroller, and the microcontroller then starts doing its pattern. All it is, it's these pairs of LEDs, 6 pairs, just being switched straight down to the negative rail by the microcontroller, and it kind of relies, the voltage across this wavered. It went from about 2.5 volts, it wavered up to a peak of about 4 volts, and that will just depend. I don't think there's any regulation going on. I don't think it's sensing the voltage and capping it. Maybe it does. Maybe it caps it from going above, say, 0.5 volts, but I don't really see how it could do that. It's possible that it might be able to do that, but I doubt it. But I think that they just rely on a given current, and the LEDs, because there's no resistor, it's only the impedance of the little MOSFET inside the chip that's limiting it. So it will effectively, the LEDs, when they're lit, will actually drag the voltage in this down. So it will probably bouncing up and down quite a bit, but it will average out round about the voltage of the LEDs. And that is the circuitry. It took a while to reverse engineer. The circuit boards, being white, with the tracks underneath that, always makes it very hard to see the tracks. It's harder than even in black because you can't see the contrast. You can barely see the outlines of tracks under there. It's quite hard to the human eye to actually see those. You have to angle it and then get the reflection off the edge of the track and then work out what's a track and what's a dip. But there we go. It's straightforward enough, and now I'll put it together. There was the switch. I've removed the switch, and I've replaced the connections onto the battery, so it's just a bit more obvious that red is red and black is black, positive and negative. But that's an interesting little light. It certainly has an interesting visual effect, and the nicest thing is it shows you how minimalist you can make an LED flame effect just by using, 6 LEDs and a little 8-pin microcontroller driving those directly. And it still produces, from a distance, a decent sort of flickering effect. So it's not bad. Not bad at all.